Hi, welcome to Expertisor Academy. This is Giri, lecturer in physics. In this video, we discuss about the working of moving coil galvanometer. See here, consider a single turn of rectangle coil PQRS whose length be L and breadth B. In galvanometer, we have rectangle coils. Consider one of them. That length is L, PQ and RS is the L, QR and PS is the breadth. Okay. Let I be the electric current flowing through the rectangle coil PQRS. I be the current flow through the rectangle coil. At the same time, this is the direction of the magnetic field. Two forces are acting on this rectangle coil, that is force upwards, force downwards. Okay. The construction of galvanometer is explained by me in before video. So visit that. This is only working of moving coil galvanometer. Okay. The horseshoe magnet has semi sorry hemispherical magnetic poles, hemispherical magnetic poles, which produces a radial magnetic field. This horseshoe magnet consists hemispherical magnetic poles. Hemispherical magnetic poles. This one creates radial magnetic field. Due to this radial field, the sides QR SP are always parallel to the magnetic field and also experience no force. So that is the meaning of radial magnetic field. Net force is zero. Okay. The sides PQ are as always parallel to the magnetic field B and experience force. Due to this, torque is produced. So look at this. There is a two magnetic forces. Two magnetic forces. At PQ there is a force and also SR or RS. There is a force. But these two forces are in opposite direction. Opposite direction. So that's why net force is zero. Magnitudes are same, but the directions are different. When you add these two forces, definitely net force is zero. Okay. For single turn, the deflection couple is tau is equal to B into F. So what is the meaning of B? This is the breadth value. This is the breadth. So that's why tau is equal to B into F. For F, that is equal to Bill, magnetic field, flow of current, length of the conductor or any side here. Okay. Convert this L into B as the area. Okay. So that's why tau is equal to area of the conductor, magnetic field, flow of current. Okay. So here A is equal to length into breadth. For coils with N turns, we get tau is equal to NABI. N is the number of coils, A is the area, B is the magnetic field, I is the flow of current. Okay. This is the torque generated in coil. Okay. Due to this deflection torque, coil gets twisted and restoring torque, also known as restoring couple, is developed. Okay. Hence, the magnitude of restoring couple is proportional to the amount of twist. Consider twist value is theta. So that's why this torque is directly proportional to twist. So therefore, tau is equal to K into theta. Tau is equal to K into theta. Okay. Here, where K is the restoring couple per unit twist or torsional constant of the spring. Torsional constant of the spring. Okay. At equilibrium, the deflection couple is equal to restoring couple. So that's why NABI, that is equal to K theta. Here I is equal to K divided by NAB into theta. So here I is equal to G into theta. So where G is equal to K divided by NAB, that is equal to galvanometer constant of current reduction factor of the galvanometer. Okay. Since suspended moving coil galvanometer is very sensitive, we have to handle with high care while doing experiments. While doing experiments, most of the galvanometer we use are pointer type moving galvanometer. Okay, most of the galvanometer we use are pointer type moving coil galvanometer. So here we have to use pointer type moving coil galvanometer. So here G is the galvanometer constant. Okay. Next, figure of merit of galvanometer. It is defined as the current which produces a deflection of one scale division in the galvanometer. It is defined as the current which produces a deflection of one scale division in the galvanometer. Look at the picture of galvanometer. Here this is the scale. In this scale we have the needle deflection. Okay, so that one gives figure of merit of galvanometer. Okay, sensitivity of a galvanometer. See this sensitivity of galvanometer. The galvanometer is said to be sensitive if it shows large scale deflection even though a small current is passed through it or a small voltage is applied across it. So, what is the meaning of sensitivity of galvanometer? Galvanometer is said to be sensitive if it shows large scale deflection, even though a small current is passed through it or small voltage is applied it. So that's why this is the information for sensitivity of a galvanometer. Next, current sensitivity. It is defined as the deflection produced per unit current flowing through it. Deflection per unit current, that is current sensitivity. Okay. See the current sensitivity. Is is equal to theta divided by I, that is equal to NAB divided by K. So finally Is is equal to 1 divided by capital G. See here, the current sensitivity of a galvanometer can be increased by increasing number of turns, magnetic induction, area of the coil, by decreasing the couple per unit twist of the suspension wire K. Okay. Next, phosphorus bronze wire is used as suspension wire because the couple per unit twist is very small. Okay, this is the sensitivity of the current. See the voltage sensitivity in the galvanometer. It is defined as the deflection produced per unit voltage. It is defined as deflection produced per unit voltage applied across it. So this voltage sensitivity Vs, that is equal to theta divided by V. Vs is equal to theta divided by IRG. IRG means this is the Ohm's law equation. RG means galvanometer resistance. So apply the twist value NAB. So finally Vs is equal to 1 divided by G into RG. That is equal to Is divided by RG. Okay, Is divided by Rg. So here Rg is the resistance of the galvanometer. So in this video we discuss the working and internal structure of rectangle coil in the galvanometer, and also two forces direction on the rectangle coil. At the same time, torque is generated by rectangle coil with n turns, and also for twisting, the torque that is equal to k theta. Torque tau that is equal to k theta. Okay. Next, galvanometer constant G, that is equal to k divided by NAB. K divided by NAB. And also here we find sensitivity of galvanometer, current sensitivity, and also voltage sensitivity. So this is the information about working of galvanometer, galvanometer, torque value of the galvanometer, and also current sensitivity, voltage sensitivity in the galvanometer. This galvanometer current sensitivity depends upon these factors. This is the voltage sensitivity. The voltage sensitivity equation form is current sensitivity divided by resistance of galvanometer. So this is the information about working of moving coil galvanometer. Okay, thanks for watching this video. For more videos, visit www.expertisoracademy.com. Thank you.